So here we've got a distance time graph, and the thing about distance time graphs is that if you think about the rise above the run, the gradient, you're going to get kilometers divided by time, which is speed. So in actual fact, the gradient tells you how fast Delina is cycling. So I'm working out here, but I've drawn the red lines. You can see I'm trying to work out how fast she's going, and I can see that she's travelled 15 kilometers in the first hour, which means she's going at 15 kilometers per hour. Whereas if I compare it with the half hour after she's visited her friend, so let's go from here, that's half an hour, 2 squares, and I can see that she's travelled 6 kilometers in half an hour, which is 12 kilometers an hour. So I'm going to write afterwards she's cycling at 12 kilometers an hour. Oops, that should be 12, not 16. I apologise. Let's just rub that out. 12 kilometers an hour. Good. And so I can answer the question now. It says give a reason for your answer, so I can. I'm going to say that before she visits her friend, Julian is cycling at 15 kilometers per hour, and afterwards she's going at 12, so clearly she was cycling faster before she visited her friend. Okay. Now for the next part, let's just show you the question. That's on the next page. Okay, so she stayed at the park for 45 minutes and she then cycled home at a speed of 16 kilometers an hour. So let's mark on the 45 minutes she didn't cycle at all. So she's still 24 kilometers away from home. Now let's just think, if she's going to come home at 16 kilometers an hour, that means after 1 hour, well the time now is what? Okay, so I think you can agree that the time is 12:45. So at 1:45, she must have done 16 kilometers. She's 24 away. 24 take away 16 is going to be 8. So at 8 kilometers an hour, she must be. As you see, I put up a little black dot, and I'm making sure that my line goes through that black dot. I've got the right gradient, and I can see that she'll be home by 2:15 or 14:15. Okay. Right, so that is more marked on the diagram now. And if I check the gradient, I can see that after 1 hour, she has actually gone back 16 kilometers. Okay, so let's look at the last part of this question, and it says what's her average speed, but not including the bits of time when she's not moving. So that's in the friend's house and in the park. Well, she spends 15 minutes at the friend's house and 45 minutes in the park, so that's an hour. We're not going to include. She's cycling between 10 and 2:15 or 14:15. So that's 4 hours 15 minutes, but an hour off, she's not cycling, so that's 3 hours 15 minutes. So she cycles 24 kilometers there and 24 kilometers back. So that's 48 kilometers she cycles in 3 hours and 15 minutes. And of course we're going to work this out in kilometers per hour. So kilometers per hour means the distance divided by the time. And the time's in hours, so it's going to be 3 hours and 15/60ths of another hour, or a quarter of an hour. So if I do that on my calculator, make sure you use the shift fraction button for that denominator, because it's a mixed number. You need to press the shift fraction button, it's very important. I think you find the answer is about 14.8, I think. Yes, it is. So there we have it. Okay. So now let's look at the mark scheme, and I'd be very grateful if you would pause that and have a good read. It matters. And here's the mark scheme in case you want to check that we got the answers right.